A fractional exponent is performing two different operations. The numerator raises the base to a power, and the denominator takes the root of the base. A to the m over n can be rewritten as a to the m raised to the 1 over n power. In this case, the numerator raises a to the power m, while the denominator takes the nth root. So another way to write this would be a to the m over n equals the nth root of a to the m. Another way to write it would be to have the order opposite, so you take the nth root of a first and then raise it to m. These are equivalent. The order they are applied does not matter. They are commutative. Here's a nice way to remember that when you have x raised to a fraction, the top is the power and the bottom is the root, like a tree. We have solar power on top, and we have roots underneath. While order doesn't affect the result, it's often easier to do the root first so the number is smaller. For instance, let's evaluate 81 to the 5/4 power both ways. If first we did 81 to the 5th power, we would end up with this huge number here, and then we would take the 4th root of that and get 243. However, if we instead take the 4th root first, we get 3, and then we just raise 3 to the 5th power, we get the same answer, 243. The result is the same, but the solution on the left would be very difficult without a calculator, while that on the right is pretty easy. Generally, taking the root first is easier. Also, there's one other property worth noting. Can you find a shortcut? How would your shortcut make the problem easier? If we start out with 81 to the 5/4 power, we can break it up into 81 to the 4/4 power times 81 to the 1/4 power, because 4 plus 1 will give us that 5. Now, 81 to the 4/4 power is the same thing as 81 to the first power, since 4 divided by 4 is 1. 81 to the first power is just 81. Now we have 81 times 81 to the 1/4 power. The 4th root of 81 is 3, and then we have some simple multiplication. 81 times 3 is 243. So if the exponent is an improper fraction, you can save time by just separating out the numerator into an integer and the fractional remainder. Simplify. Alright, so we have 16 to the 3/4 power. Let's rewrite this as 16 to the 1/4 power raised to the 3rd power. So this is equivalent. Now that means that is the 4th root of 16 cubed. The 4th root of 16 is 2, and then cubed gives us 8. Here we have a negative exponent, so in order to make that positive, we're going to make this 1 divided by 4 to the 5/2 power. So let's deal with this root first. The second root is the square root. So we have 1 over the square root of 4 raised to the 5th power. The square root of 4 is 2, so we have 2 to the 5th power, or 1 over 32. Here we can take the 4th root of 81 and then raise that to the 3rd power. The 4th root of 81 is 3, raised to the 3rd power is 27. Here are the answers. Simplify. Alright, so here let's deal with that negative sign first. In order to make this a positive exponent, we're going to flip the fraction. That makes it 16 instead of 1 over 16. Now we have 16 over 1. So now we can take that and raise it to the 3/4 power. That means taking the 4th root and then raising that to the 3rd power. The 4th root of 16 is 2. To the 3rd power is 8. Here we can first take the 3rd root of 1 over 8, which is the same thing. Well, we'll continue this to the 4th power. So this is the same thing as the 3rd root of 1 divided by the 3rd root of 8. The 3rd root of 1 is 1. So that's just 1. The 3rd root of 8 is 2. So we have 1 over 2, and we still have that 4th power. So let me write that in here. And raise that to the 4th power. 1 to the 4th power is 1. 2 to the 4th power is 16. And there we go.